Okay, so dear student, today we start the next chapter, chapter 2, electrostatic potential and capacitance. So first we recall what we studied or what we learned in the last chapter. In the first chapter we learned about mainly the concept about charge and the force between the charges and the many formulas related to that force, electric field. Okay. So first of all, we studied that the charge concept about charge. What is charge? It is a property of a matter that, or it is a property that produces an electric field. Okay. From there, we learned two types of charges: source charge, test charge. Another two types: positive charge, negative charge. Positive charge directed outwards, negative charge directed inward direction. And the many formulas, electric dipole and many formulas related to electric field and the electric dipole, we derived that formulas. So in this chapter, so up to that we learn this formula: E equals to F by Q, force per unit charge. But after that force, what after that force? After the force, what we calculate in electric field, what we get, what we discuss, what topic we discuss, that is the second chapter. And from here the second chapter is started after force. Okay, so force equals to, we have E into Q, E equals to F by Q, so F equals to E into Q. And we know that if the force is applied on a body, it will displace from its position, and force, when that force is multiplied by that displacement, we get work done. We know that definition of work done is force into displacement. So we know this formula, F equals to E into Q. But what after that force? When a force is applied, a body displaced. That means the force multiplied by displacement, that is called work done. So work done equals to F into D. And we know that the work done is stored as a energy. When the object is at rest, that is called potential energy. When the object is at motion, that is called kinetic energy. But the work done is stored as a source of energy inside the body. Okay. So in this chapter, we for this chapter, because this is related to electric field and electric charge, okay, so this kind of energy for this chapter, this is called electric potential. And we also studied electric potential and potential difference in class 10. In this class 12, we derived some formulas related to this electric potential. Okay. So mainly here we find out the work done, and that work done converted to potential energy. So because this is a electric charge, electrostatic, it's a static electricity chapter, is the static electricity. So that potential is called electrostatic potential. Now let's discuss about the electric potential and potential difference. Okay. So in electric field, we know that the electric definition of electric field. So electric field around a charge can be described in two ways. One, we already derived, that is in the form of electric field. Another one by the electric potential. Which one we derive now, or which one we learn now. So, but in this two, electric field is a vector quantity, but the potential is a scalar quantity. Okay. Electric field is a vector quantity, but the potential is a scalar quantity. Now, what is electric potential? Electric potential always we calculate at a particular point. Okay. Inside the electric field. That means when we get the electric field, any charge, if we placed any charge anywhere, that charge creates a electric field around it. Okay, and that charge is called source charge. And if we bring another charge inside that electric field, that charge is called test charge, and that will experience a force by the force charge. So that force is always a repulsive force if the charge of that two charges equal. That means if positive or negative, the repulsive force is experienced by the source charge. Okay. So what is electric potential? Electric potential at a point. When you define electric potential, you must mention this one, at a point, because always we define electric potential at a particular point. Okay, that means it has a magnitude but not the direction. That's why electric potential is a scalar quantity. Electric potential at a point in an electric field is the amount of work done. Here we already discussed that in this chapter we find out the work done. Okay, when a force is applied on an object, it will displace. So force multiplied by displacement is equals to work done. So the amount of work done in moving a unit positive charge from infinity to that point against the electrostatic force is called electric potential. How we describe it? Suppose this is a electric field of any charge Q. Okay. Another one charge Q naught, it's placed infinity. If we bring this unit positive charge inside this electric field, what happen? It will experience a force by this source charge, and it will repulsive force. That force must be a repulsive force which repels this charge. So but we bring this unit positive charge against that electrostatic or against that repulsive force. That means when we apply a force, when we bring that unit positive charge against the force, it must, there's a one work has to be done by the electric unit, this test charge. That amount of work done per unit test charge, this is called electric potential at this point. If we consider this is a point A, at point A this will be the electric potential. Understand? So electric potential is defined as the amount of work done in moving a unit positive charge from infinity to that point against the electrostatic force, because either it will be repulsive force or the attractive force. So mathematically we can write electric potential is denoted by V, work done per unit charge, W by Q, and this Q must be this test charge, not the source charge. Which charge you bring from infinity to that point, that charge you write here. If this here we mention this is Q naught, so here also you mention this is Q naught, not the Q. Clear? And the SI unit of electric potential, we know that this is volt. So how we define it? 1 volt. So 1 volt equals to 1 joule by 1 coulomb. So the electric potential at a point in an electric field is said to be 1 volt if 1 joule of work has to be done in moving a positive charge of 1 coulomb from infinity to that point against the electrostatic force. So 1 volt equals to 1 joule by 1 coulomb. Then work done is 1 joule and the coulomb is charge is 1 coulomb. Now what is electric potential difference? That is the electric potential at a particular point, infinity to that a point, particular point. Okay, but the electric potential, how we difference? So suppose this is a source charge, it creates an electric field around itself, and we consider 2 points A and B. At point A, the test charge is situated from infinity to that point, at point A. Okay, that A point also be inside the electric field and B point also the inside the electric field. Now, so when we bring infinity to at point A, that is called electric potential at point A. Now, inside this electric field, when we move this unit positive charge from A to B against the electrostatic force, this is called electric potential difference. That means when we move this unit positive charge against the repulsive force, one work has to be done by this test charge. And we know that the work done is stored as a energy, and this is called electric potential energy. So at point A, A has some initial potential. When it moves from A to B, so B also gets some potential. So it creates a potential difference between the 2 points A and B. So how we define the electric potential? The amount of work done in moving a unit positive charge from one point to another point against the electrostatic force inside an electric field, or inside a electric field. So when we move this unit positive charge Q0 from A to B, a work has to be done in moving against the repulsive force exerted by the source charge Q. So how we write the mathematically? We can write delta V equals to VB minus VA. If we consider the potential at point B is greater than potential at point A, so VB minus VA. But if you consider VA greater than VB, then you can write VA minus VB. Okay, so delta means the difference. This delta is denoted by difference. So delta V equals to VB minus VA. VB minus VA is that is equals to work done along A to B, WAB by test charge, that is Q0. So that means we see that this one and this one, this two formula is equal. Just here we denoted by delta V and here only the V. But when we solve the any numericals, we ignore this delta. Directly we write V equals to W by Q naught. And same, the unit is SI unit is volt. 1 volt equals to 1 joule per coulomb. Now from the above diagram, from this diagram, if we consider this point A lies at infinity. Okay, we consider here in this chapter, we consider that if any point located far away from the charge, the potential at that point we consider 0. So if A point lies at infinity, the potential at point A will be 0. So in that case, from this equation we can write delta V equals to VA equals to 0. So VB, so that means only the work done W by Q naught. So now this one and this equation equal to each other, because this is a particular 1 point VV and this is also a particular 1 point. Okay. So, but this is a condition. If in between 2 points, if any 1 point lies at infinity, then the potential at that point will be 0. Okay. So in this above definition of the electric potential difference, we have assumed that the test charge is so small that it does not disturb the distribution of source charge, and we apply so much external force on the test charge that it just balances the repulsive electric force on it, and hence does not produce any acceleration in it. Okay, that means whatever the external force we apply on a test charge, it balances that repulsive electric force and it does not produce any acceleration in it. Clear?